Okay. So if you remember last week, we spoke so much about control flow, right? And control flow is when you have some set of code, right? And you are trying to give condition, right? So when you have a set of command, a set of script, like we have here in the example we use, then you can give a condition to Python, and Python will say, okay, based on this condition, if this condition is true, this should be your output. If the condition is not true, this should be your output. And we use some of the control flow statements. We use if, we use elif, and we also used else. So what that means is, if your first condition is yes, print this statement. If your condition is not true, right? If that first condition is not true, you give another condition to Python. And if that second condition is true, it's going to print, there will be an output. So if age is less than 15, means you are not qualified for this scholarship. I'm just giving us an idea of what you did last time, just to refresh. Elif, that is, if this first condition is not met, then look at this new condition. If age is also greater than 20, means you are not qualified for this scholarship. Now, yes, that means if these two statements are not met, what should be the situation? What should Python do? And the statement says, if the first and second conditions are not met, then Python prints, congratulations, you qualify for this scholarship. So that is a set of, that's what is called iteration or iterative statement in programming language. So iterative means you have a set of code with certain condition. So when you give that iterative statement to Python, Python will read through each of them and it's going to give you an output depending on the condition. So if the conditions are met, there's going to be an output. If the conditions are not met, based on the code that you've written, there will also be an output. So the conditions we have in this statement for this scholarship we did last week is, if the first condition is met, print you are not qualified. If the first condition is not met, then look at the second condition, print you are not qualified. So the last one, so if these first two conditions are not met, then this should be the output. And that is exactly what we did last week. So let's also look at this another example that we are not able to do last week. And that's talking about writing a function that accepts two arguments. It uses modulus to return true. So remember, when we're talking about modulus, when you divide a number by another number, it is going to give us the remainder, right? The remainder is what it's going to give us. And don't forget, we talk about this divine function, def function. So let's say we are looking at divisible. So let's say x, y, comma, z equals to 10. So what that means, so if you now say if x divided by y, if x modulus y equals to 0, give us return true, give us true as answer, right? But it's not, if that condition is not met, then print the value of z. So do we get that now? So, and I told you, when you have this divine, it means all you just need to do is it's not that every time you'll be changing the values here. You already define the value, so all you need to do is to input your value. So now, we say define visible in bracket x, comma, y, comma, then z is equals to 10. Now, so if the remainder of x divided by y is 0, print or return true. S plus the value of z. So this example that we have here, so this is our divine definition, visible in bracket, x is 10, y is what? Y is 3. So if you print, if you run this code now and we run this, the answer is 10. Can anybody tell us why the response from Python is 10? Can anybody give us an answer to that? y, so that means z is printed. So that means when you divide 10 divided by 3, right? What is the remainder? The remainder is 1 and not 0. Do we remember that? Let me show us what I mean by that. I think I said that. So let's have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's divide this by 3. 1, 2, 3, right? 1, 2, 3, right? 1, 2, 3. So what is the remainder here? 1. So, and don't forget the statement you said is if the remainder of x divided by y is equals 0, then return true. But if it is not true, if this condition is not met, print z, and z is what? 10. So when you divide 10 divided by 3, the remainder is 1 and not 0. And that is why we are getting this. So if you repeat this for, let's repeat this for divisible, let's say divisible, right? Let's make it 10. Our x is 10, our y is 2, right? Let's print this. Can you see what is the response? True, isn't it? It is true, because when you divide 10 by 2, the remainder is going to be 0, and that is the condition we've given here. I want to believe. Do we understand that? So that's that. Now we are still working with iteration, and I said to you, iteration is a set of code that Python will keep running until a particular statement, until the condition is being met, or we can also call it loop. So let's look at a while loop. A while loop repeats a statement as long as some condition is true. Now, when you use while operator, when you use while, it's going to keep checking over and over until that condition is met. So let's say x is equals to 5. So while x is greater than 0, print x. Do you get my point? So we are saying x is equals to 5. As long as x is greater than 0, right? Print x. So let me take off this part of this. Let me take off this part of this code out for us to understand. Right? So as long as x is, can you see? Now, this is what I want to show to you. So what this is saying, x is equals to 5. Why x is greater than 0, print x. So Python is going to keep on checking this. So this is the condition. So when you use y statement means Python will look at it. So in this case, what is the value of x? 5. Is x is 5 greater than 0? Yes, right? So print x. So what is the value of x? 5, sorry. The value of x is 5. So that is why infinity, this code will keep on giving us 5. Can you see how long it is? 5, 5, 5 forever. It's giving us 5. It will keep on giving us 5, right? Now, let me now show you the difference. Let's now do this now. Let's look at this. Now, let's say x equals to 5, right? Y x is greater than 0, right? Okay, sorry. And then print x, right? Now, another thing that we need to do now is this. Now, what I just have here is, I think I should, okay. So before I go there, let me show you one particular thing. in Python that is very, very important for you to understand that case. Let's say I define y, I assign y to be 6. Do you get my point now? So y, so I say if I should type y, so if I should print y, so y is equal to 6, right? So what is y? So I print y. Why is this not running? Okay, sorry, I didn't. Why is it not showing for me? Okay, now when I say y is equal to 6, if you want, I can say okay, y is equal to y minus 1. And y is supposed to give me an output. Guys, let me try to start the kernel. You want to start the kernel? Yes. Okay. Okay, yeah. Now look at this. Sorry. So when you are running a script and it's not running like that, all you need to do is restart your kernel. The kernel is like the interpreter of Python. Now look at it. Y is equals to 6, right? And I said y is equals to y minus 1. So it's y. What that means is y is equals to 6. So y is equals to 6 minus 1. Now it's y. That is why y is equal to 6. This, what I did here, does not affect the original value of y. So if I put y, so it affects the original value of y. So now I've updated y from being 6 to what? To 5 by just typing y is equals to y minus 1. If I say y, right, is equals to y minus 4, print y. Can you see y is now 2? If I print y is 2. Do you get that now? So y is equals to, so when you put a variable and you put that variable minus a value, it's going to assign a new variable, y minus that variable. Now, this is where I'm going. If you look at this example, I said x is equals to 5. As y x is greater than 0, print x. That means this statement means Python will not keep going. Python will start. That is why this is called iteration. Python will keep repeating this statement, this particular statement, y x is greater than 0. It will keep repeating it as long as the condition is true. Do you get my point? As long as the condition is what? Is true. So when I say when y is equals to 5, y x is greater than 0, it's x. So the first thing that Python will do is x greater than 0? Yes, print value of x. X is 5. And that is why you see all this lot of x, all this lot of y, 5, 5, 5, 5, 5, 5 being printed, right? But there is a way you can also do that and stop it by the time the condition is not met. Now, let's look at this one now. X is equals to 5. Yx is greater than 0, right? Anytime you use, don't forget, anytime you use if, for, s, elif, y, define the def function, you have to put a colon and an indent to start with an indent in the following statement. Don't forget that. So ys is greater than 0, print x, right? Now, we now update that now, this time around, make x, so you can write it in two ways. You can say x is equals to x minus 1. Or in another way, you can say x minus equals to 1. let me show that example here for us. So don't forget our y is now 2, right? So I can say I can say y minus, right, equals 1. Okay, sorry, I don't want to confuse you guys. Let me take this out. So let me use this. With time, we will improve on that. Now, what I'm not doing now is this. So yx is greater than 0, int x. X is equals to x minus 1. So what I'm saying here to this program is, when you first of all take x is equals to 5, right? It's greater than 0, right? Int x. So the first time, s is what? Is 5. Now it's going to x. Let's run this command and see what happens. Now, so what is saying? The first place, this is, don't forget, this is iterative statement of code. Python will run it the first time. If the condition, it will go back again and check if that condition is still true. If the condition is true, it will run it again. It will go back and check again. If the condition is true, it will run it again. Now, yx is greater than 0. The first value of x is what? 5. 5 is greater than 0. Print x. That's why it prints x to be 5. Right? Now, when it comes here, now x is no longer 5. Now x equals to 5 minus 1. That means our x is 4. X is 4. It will go back to this statement again. Is x, now that is 4, is it greater than 0? If it is yes, it's greater than 0. X is 4. That's why we are saying this 4. If you take this 4 again and put it here and say 4 minus 1, that's 3. Is x, that is 3, greater than 0? Yes, it is greater than 0. X is 3. Can you see? Now, go back again. 3 minus 1, that's 2. Is 2 greater than 0? Yes, it's greater than 0. 2 is now, sorry, x. X is 2 now. If you take that x again back to this place, 2 minus 1, that's 1. Is 1 greater than 0? Yes, it's greater than 0. Print x. X is 1. You take this one back here. 1 minus 1, 0. Is x greater than 0 now? No. We now said if this condition is no longer met, print blast off. And that is why when it's after 1, it prints blast off for us. So you can use this statement set condition. Let me give you a practical example. When you are using your phone, right? I know if you mistakenly press your phone password wrongly, maybe like 3 times or more, it will tell you can't do anything, that you have to wait for a certain time. In the setting of that code, it has been inputted in that code that as long as your entry of your password is more than 3 times, it should lock, the phone should lock off. That is exactly what they've done. So let's see if we can do something similar to that. So let's assume that, okay, let's try this. So let's assume we have, let's say, P password equals to 1, 2, 3, 4, right? Okay. Oh, I want to create that code of that phone password for you. And I'm trying to see how that works. Just give me 1 second. Let me try to think. So if password is 1, 2, 3, right? I think that will take me time to, I can think it, but that is going to take me time. So let's just do, let's say password is equals to, let's say the password is equals to 10, right? So y password is Y password is, let's say Y password is less than 5. Print password, right? Now, let's now say password equals to password. So in apart from this style, password password plus, let's say plus, let's say minus 4. You understand? You can write it. It's the same thing as saying password minus equals to 4. It will automatically remove 4 from password, right? So can say print stop. Let's type this code now. Can you see? So in this case, it's saying stop. Now let's go back to the condition. We said our password is equal to 10, right? So why password is less than 5? Right? Print password. So password is equal to 10. Why password is less than 5? So is password less than 5? No. So why password is less than 5? Print password. The now see password is equal to is 4 minus password minus 6. So let's see. Password is equal to 10. Why password is less than 5? Yes. Print 10. So is password less than 5? Any response? Hello?
No, sir.
No. So since password is not less than 5, then that's why it's giving us stop. So it's going to print the value of password only if password is less than 5. But because password is not less than 5, that's why it's giving us stop. Do you get that now? So let's say if password is greater than 5, print password. Let's see what is going to happen here. Can you see? So now we've changed the code now, the condition now. If password is greater than 5, print password. So the first thing, what is the value of password? The first value of password is 10. Is 10 greater than 5? Yes. Print password. Because value of password is 10, is greater than 5. That's why it's printing password 10. It goes back to this again, because you already put this that password should be minus 4 now. So the original value of password is 10 minus 4, 6. Is 6 greater than 5? Of course, yes. That's why it's giving us 4, 6. It go back again. The value of password now is no longer 10, is 6. 6 minus 4, that's 2. Is 2 greater than 5? No. That's why it's giving us stop. Is it clear? Or I should explain that to us? Hello?
It's
clear,
clear.
Dr. Ewo.
Okay. So this is called iterative because when you use Y, right, it will keep checking if that condition is still intact. The moment the condition is not intact, it will do whatever you ask it to do. So what this statement says is, as far as this statement is true, continue to print the value of what? Of password. The moment the value is not true, again, just give us stop. That is it. just print stop. That is the end. So let's also look at, then we can also use this for list. Now, don't forget, we spoke a lot about list, right? So when you have this sharp and bracket, that is when you have list. Dictionary is when you have the curve bracket. That's dictionary. But the sharp bracket is list. The curve bracket is dictionary. Now, look at this now. Now, so what that means is my list. So my list is equals to open. This is open, right? Now, when you have list, don't forget we can create list by assigning a value, right? You can say our list is maybe 1, 2, 3, 4, 5, 6, right? But another way you can give an open bracket, like a blank bracket. So my underscore list is equals to this bracket. Now, x is equals to 0, right? Why x is less than 10. Now look at it. Why x is less than 10. My list, if you add the value of x to my list, right? And also you can make x plus x equals to x plus 1. Let me give us this example. So that you can understand. I remember we talked about this append in list. Let's say we have my class. I just want to refresh our memory. My class equals to, let's say this is the list of in our class. Let's say 10, 12, 11, 0, right? 2, for instance, right? Now let's say these are the people that are in my class. I have just 4 guys, right? Now, adventure, another student came, right? Let's say we have a fifth, another student, making 5, and I want to include that student age. Maybe the student age is 6 into that list. You can say my list, my underscore list or class, class dot append. Append is how you add new value to a list. Append. Let's say the age is 6, right? Run the script. My class is okay. I think I didn't run this. Okay, because I didn't run that. Now, so now if I should ask for what is in my list now, my underscore list or class, class. You see now. Let me show you. Let me show you the class. My underscore class. Yeah. No, sorry, so let me try to cut this. I want you to understand this very well first. Let me cut this. So I have just 4 guys in my class, right? So, and I have their age 12, 11, 0, and 2, right? Just 1 second. So I have just 5 students. Their age is 12, 11, 0, and 2. Now, we now have a new student in our class with age of 6. Its own age is 6. So if I want to add that new age to the age list that I have already, just put my underscore class, right? Dot append is how you can add. Instead of me typing 6 here, I can decide to just 6, right? Instead of doing that, all I need to do is just go to your value variable dot append, then put the value that you want to add, the new student's age, there, and run the script. So if I should check for my list now, my class, my underscore class. Now, can you see 6 has been what? Has been added to it. Did you get that now? So let's go back to the script. So in this place, I have my list, right? I have my list. So I have my list. So my list is open. I didn't assign any value. I just show that my list is a list, is a data type list, right? So I now said x is equals to 0, right? So why x is less. So what I want to do is I want to assign a number from 0 to 10 my list. Just in this place, I type it myself. I just type the value. But now I want to use a style of adding those value into my list. So why x is less than 10, right? Add my list dot append x. So in this empty list that is here, as far as and I said the value of x is 0, as far as the value of x is less than 10, it will add the value of s into this list, right? So I now said, okay, let x equals to x plus 1. So the first thing that will happen here is, and I said, so the first thing that will happen here is, what is the value of x? 0. Is 0 less than 10? Yes. Now, append the value of x into this list. So in this command, the first thing that will come into my list is 0. Can you see? 0, right? If you go back again, the value of x is 0. So x plus 1, that's what? That's 0 plus 1 is 1. Is 1 less than is greater less than 10? Yes. It add x 1. Now, the value of x is no longer 0, it's now 1. If you come to this place again, add 1 to 1, making 2. Is 2 less than 10? Yes. It will add 2. So it will keep on adding 1 to each value of x until it gets to a point where this condition is no longer met. So after 9, 9 plus 1 is 10. Is 10 less than 10? No. That's how it stops. Then it will stop. Is it clear to us? Is it clear?
Yes, sir.
Okay. I know this thing is, I understand, is it may be like, is this Arabic or what? It's not. It's just, that's why it's called programming language. It's programming, right? And I used to say it's similar to, like, it's the same way as you want to go and learn a new language. So you have to do this in a language that Python understands. So it is as simple as that. So it will keep asking for the value of x equals to 0. Let's do something else. Let's do something. Let's say we want to add the number from, let's say, from 20. So let's say we want to add even number. We want to add the even numbers from 20 to 40. That is what you are interested in. Even number from 20 to 40. So my underscore, let's say even, right, equals to this. Sorry, this, right? So it is going to start from what? From 20 to 40. We are only interested in even number, not odd number. So let's say our y equals to 20, because you are starting from 20. And fortunately, 20 happens to be an even number, right? So y is less than, don't forget, we want to stop at 40, right? And don't forget, 40 itself is also an even number. So y is equals to or less than 40, right? Don't forget to put colon. So we now say my even dot append, right? Y. Now, if you look at this statement that I just put now, if I should run this statement, it's going to add only 20. now, but what I want in my list are just even numbers only, no other number, just even numbers only. Then I need to make y to be equals to y plus, if I should add 1, that means it will start from 20, 21, 22, 23, and 21, 23 are not even number. So it will be 2. So it will be 20, 22, 24, 26, and those are even number up to what? Up to 20. So once we are done with that, tell it to give us my even number. So let's run this. Sorry, this is not supposed to be equals to. So what do you know what that says? It says this is not, so it will be less than or equals to. So it's not equals to less than, it's less than or equals to. So can you see what happened here? Can you see how this program give us all the even numbers from 20 to 40 and assign them into my underscore even? So if you click for what is my underscore even now, it will give you all this list. My underscore even. Can you see? Do you understand? So this thing is understanding. So we need to follow the trend and the language of this part of Python. So can you see what we did? So we create, instead of course we can just decide to say my underscore even is equals to give this bracket and type all this number. Yes, it's possible, but there may be some, to be more than our average when it comes to Python, you have to understand all these gimmicks. Yeah, let me just say that. You have to. So let's look at this. Create a list of even number. I think I've even added it here. So create a list of even number. So we have even number is equal to 2, 4, 6, 8, 10. Even underscore number dot append. Now, can you see how they append 12 without typing it? Can you see that? So that's way. So iterate through the list, each element multiply by 2. So at the same time, you can also print through a list. For instance, let me first of all do this. Let's say, and don't forget I've used the 4 in the past for item or for I instance. No, I have to define, we've defined even for I in even number, right? So for I in even number, print I. So that I means item. Can you see? So if maybe you have a variable and you are not sure what are the values in it, you can see for I, that's item in even number. So for every item in even number, please print I. So it will print for us what is the first item in I, 2, the second one is 4, the third one is 6, the fourth one is 8, the fifth one is 10, because it's 12. Can you see that? Now, at the same time, you can also multiply whatever you have in an even number by saying for item in even number, print item multiplied by 2, or you can use I, any value that you are using, right? So either I or item. So for item in even number, that is all this, print this multiplied by 2. So for the first one is 2 multiplied by 2, 4, 4 multiplied by 2, 8, 6 multiplied by 2, 12, 8 multiplied by 2, 16, 10 multiplied by 2, 20, 12 multiplied by 2, 24. Is that clear? So these are iterative statement. It will keep going. So the first thing is going to 2, perform this, go back to the next one, go back to the next one until the last one, or until the condition that you have given is no longer true. Now, let's look at another example here. How do you print out only the integer in a list? For instance, print out only the integer in a list. So we have my list. We have, this is a new my list, 3.2, 19.75, 6, 3.3, and 8. And we all know what integers means. Integer means a whole number, right? So if you want to print only the integer from this list, how do you do that? Now, for element, now they use element. They can use anything. You can use I, you can use item, you can use element, you can use list. Just don't use list, because list is a function, is a data type in Python. So for element in my list, this one, if instance, now look at it now. If instance, don't forget what instance we talk about. Instance, maybe last week. Instance is to check if a particular type of data is present in your is part of your values in a variable. So if instance element is an integer, print element. So what this means is, if, for instance, the element in this my list happens to be an integer, then print it out for us. When you look at it, so it print out 6 and 8, right? So what that means, it's only looking for integer. So let's do similar thing for, let's say we are looking for float, right? So let's do something similar for float. Let's say we are looking for float. We are looking for float. Now we are looking for, let's say my list, right? My underscore list. Let me just, my underscore list. We already have this. So my underscore list, right? So for I in my underscore list, right? If instance, right? So if in instance, right, is, so I, right, comma, then float. Can you see? Print I. So if what you are interested in this case is want to look at the float in this list, it will print out for you. Now let me tell you something. You may be asking, why are we printing out float? Because at least you can see them. We can see from my list, you can see float, yes. But when you are working, at some point when you are working with data, you can be working with data with over 20 million values, or 1,000,000 values, or thousands of value. So now you want to see if there is any missing data, for instance, or if there is any data that has maybe what you are expecting should be, for example, if you're asking for people's age, maybe you are asking for people that have attended TSU, for instance, you're asking for their age, or the alumni in TSU, I know at TSU alumni can be less than 100,000, right? And they gave you a data that this is the data of all the alumni from TSU. But the problem with this data is we ask them to write their age, and some people mistakenly put their age dot their month. So maybe their age is 40. Some people now put 40 years dot 3 months. So 40.3. So now ask you as a data analyst or as a Python expert, anyone that has 40 points or any float number, do not include them in your analysis. And you have a TSU alumni of over 100,000 alumni. So tell me, are you going to start looking at their values one by one of over 100,000 values? How many days is that going to take you? Of course, it will take you some, even if you can finish it in a day, it will still take you some time, right? But instead of doing that, you can use this function. It's okay. For item in PSU alumni. If instance item, comma, is equals to float or is equals to integer or float, print. Then it will tell you how many of those people that fill the form actually put their age in points in float format. And because you have been told not to include those float formats, you have to take it away. It will be easier for you to use this function than you looking at everybody's age one by one of over 100,000 individuals. I hope we are getting this, right? So let's go. So another, I think we've spoken about range in the last time. You can also use range. The range function return a list of number from 0 to n. So if you want to create a list, right? You can use range function. So for this one, so it's going to create for you range from range of 0 to 10, right? So you can say, okay, let me give an example. Let's say age equals to range, right? Let me put 20. And let me not put, sorry, 200 is too much. 20. Let me say age. Can you see? So what this is showing you is the age range is from 0 to 20, right? Now, because the range goes up to but does not include the ending number, right? You can add 1 to capture it. So when you are forming when you form a range, it doesn't include the number that you specify. You can add 1 to capture that particular range that you are looking that you want. So for instance, like what we have here, if you look for the range of this, it's going to be from 0 to 19. So if you want 20 to be included, you can make it 21 so that 20 can be included. Right. So also range optionally let you specify a starting number, an ending number, and a step as argument. Now, if you look at what we have here, it automatically start from 0 to 19, right? But you can also add range. You can also specify what number do you want it to start, what number do you want it to stop, and at what interval. What that means is, let's say I want to create a list from, I'm not starting from 0, I'm starting from 2, and let it stop at 12. Then I don't want odd number to be in that list. So maybe you don't want 3, you don't want 5. So we can now say let there be an interval of 2. So it will be 2, 4, 6, 8, 10, 12. That is the purpose of signifying these 2. If you want it to be 3, you can put, okay, maybe you want it to be a 3 interval, maybe like 3, 6, 9, like that. You also put this. So that's one of the function of, so I've specified that here. You can do the same thing with variables. Start is 2, end is 12, the step is 2. So the step, it will be 2, 4, 6, 8. So if you want to use that format, this is what this means. The first letter is going to be the start number. The next one will be the end number, while the last one will be the step or the interval you want between them, right? So iterative to the list, putting each element multiplied by 2. I think we've done this So for element in number, right? Now look at this. So if you look at this, we already make our range is it starts from 2 and should end at 12. And we want the range between them to be 2. So we can print that out, say, by saying for number in numbers, this is our variable. Or you can say for I, not to confuse us, for I in numbers, our variable is this. Don't forget we've specified the range. Print I. So before I do, let me first of all, let's print I. Sorry, print I first. So can you see? Don't forget we already set our range to starting point, 12, the end point, and 2 is the step. So That is the number now. 2, 4, 6, 8, 10. So you start from 2, 4. That's the number. That's the number now. So at the same time, you can also sorry, you can as well multiply that. You can also multiply that by 2. So you can as well multiply that by 2 by saying I multiply by, let's say, by 4, not even 2, any number by 4. Can you see? The first is 2, multiplied by 4 is 8. The next one is 4, multiplied by 4 is 16. So that's how to do that. So another example is here. For x in this range. So in this place, you can decide to assign a variable. So we assign this range, this list, to a variable. And another way, you can do the same thing more concisely without assigning a variable. So for x in range 2, 12, 2. That means starting from 2, end in 12 with step 2, print x to multiply by 2. So you can do that without even assign. In this case, in this instance, we assign this range to numbers, right? But in this case, we didn't assign a variable. We just work with range directly. Do we have any question? Do we have any question? Okay. Now, list comprehensive let you create a list based on some expression. Right. So you can also create a list based on some expression. For instance, we have new underscore list equals to list. This is the sign for list. X for x in range 5. Can you see? So don't forget range 5 is from 0 to, and I told you when you put 5, that means you start from 0 and end at the number before the one you specify. So when we put 5, it starts from 0 to what? 4. From 0 to what? To 4. So if you want to include 5, you have to put 6, then it will include 5. And things like that. So let's see. So list, yeah, so you can perform operation within a list. Yes, you can as well perform operation within a list. If you look at this, x plus 1. So for x in range, so what that means, add 1. Don't forget this is our range is from 0 to 5, right? So we are now saying x plus 1. So for every x in 0 to 4, add 1. That's what this means. This is what it means. So we are just trying to show different ways you can manipulate your range, and you can manipulate your stuff, your variables and your list and values. Because when you are working with big data, different data may require different method of working with them. You can use list comprehensive to convert a list into integer, to a new list of string. So you can also convert a list to an integer. If you're interested, so for instance, let's say, we have this string is 2 multiplied by 2, x multiplied by 2 for x in range this. So let me try to cut this down for understanding. Right? So you can decide we can have, let's say we have string, right? String underscore list equals to, so we can say our list is x, right? For x in range let me use 4, 20, and 5. So it's going to start from 4, end at 20, then the interval should be 5. Bless you. Let me say string underscore list, right? So can you see now? Can you see how we form a new list? So we create a new list for x. So for x in range of 4, starting from 4, at 20 with a step of 5. So 4 plus 5, 9, plus 5, 14, plus 14, 19. Can you see that? So at the same way, this is a list, right? We can decide to convert this to a string. So by saying string, right, underscore list is now equals to, do you get that now? So it's still a list, but it's going to be a string now. Everything will be string into bracket x, right? For x in range 4, 20, 5. So let's string underscore list. Okay, what is? Can I stop there? What is that? What's to me? Oh, okay, sorry, I'm supposed to put this. Yeah. No. Okay, the problem is there. Okay. Right. Can you see? So the difference between what I have here is a list, right? And having them as a list, but these are integer. But now I've successfully converted them to a what? To a string. Can you see? So what we do in this two step is what is being done in a single step here. So let me say this is very important. When you are writing a Python code, don't compulsively say you want to write it the way Dr. Idowu is showing to you or the way Dr. Scott explained to you. Just make sure you write your code in the way that you understand most, right? If you can do these two steps that I did in just one step like this, fine, you. But if you can't do it, if you don't understand up to that level, but you can do it in 2 steps, or even you can do it in 3 steps or 4 steps, but at least at the end you will still achieve the same thing. You are free to do that. It's not compulsory that you should operate on the same level as I am, with the same level with Dr. Scott. Just try with your own level, and with constant practice, you will start upgrading yourself. So if you can't do this in a single step like this, do it in two ways, like I've done my own, or you do it in multiple ways. Do you understand? So this is the same thing as this. In fact, another way you can also do this is you can just key directly to string. Just say str over string, right? Underscore list, right? Can you see? Since you already define this, just put string without you doing all this stress. That's another alternative. It's still the same. So what we have here is the same thing as what we have here. Since you already assign the values to this string, just put the conversion string in bracket string underscore list. That's all. So whichever way that is easier for you, you may not be able to compress code script like I am doing, or like the Scott is doing, but just try to put it in the way that you understand. Just put it in the way that you understand. So any questions so far? Do we have any questions so far? Any question from anybody?
No questions.
Okay. So let's go to functions now. Functions, I dare to put some notes here so that it will be easier for you to. Function play very important role in any programming language. They take some input as defined by the user and do calculation or do modifications to existing data. Finally, return the output. So there are some functions already in Python, just like packages and modules, that all you just need to do is to import them. For instance, if you want to do mathematical stuff, just normal mathematical stuff, you can import, just import math, right? So if you want to calculate the radius, the area of a circle, for instance, and I don't know if you want to calculate the area of a circle, just define circle underscore area, then radius. So area is equals to math. So math is going to do that. And don't forget, do anybody remember the normal formula for area of a circle? Do we have anybody that remember the area of a circle?
Should be pi r squared.
Pi r squared, thank you. So you just put the area is equals to math dot pi multiplied by r squared. Do you see that? So pi math dot, so you want to do a mathematical area is equals to math pi, right? Multiply by square of what? Of radius. So, and since we already defined circle, so all you need to do is always put your so if I have a circle now, all I need to do is to put the radius of that circle. In this case, 2 is the radius of this circle. So the area of a circle that has radius 2, this is the value. And this is the area of a circle with radius 2. So since we already defined circle, so we can go back and okay, let's calculate for another circle with radius 10.6. Can you see? So because you don't forget, when you use this function def circle underscore area in bracket, you see is radius. So whatever you put here in this is radius. So that means automatically it's doing the calculation for us. Just supply the radius, and what it will calculate the value for you. That is that. So all these functions are already there for you to make use of. But like Dr. Scott said, you have to read, so you have to understand what your work entails. I'm just showing all this generally because majority of people on this call are pharmacy students, right? So what you are doing currently is you are trying to lay a basis. Let me say that. And very soon we will start to deviate into biomedical research, drug design, calculation of IC50, and some other projects like that. So what you are doing currently now is you are just trying to lay a basis of what Python is generally all about and introducing us to the Python script. That's to the Python programming language. That's what you are doing. So very soon we start deviate into looking at biological research, drug, and some other stuff as an example of project that we are going to do. So let's look at this example again. How many times does the value 3.3 appear in my list? Right. Now, how many times? So if you want to count now, how many times does 3.3 appear in list or my underscore list? How many times does it appear? To do that, we define that to be count underscore occurrences in brackets my underscore list. Now, initialize counter to keep track. Now, if you look at this, count is equals to 0, right? For element in my list, if element is equals to 3.3, right? Count equals to count plus 1. Now, this is something that is very, very important. I want you to listen to this. Our objective is we have a list, right? Call my list. So we have not defined the list, and we can create anyone. So now let's use this for example for us to understand. So in this list, we have 3.3, 3.1, 4, 2.1, 1.2, 3.3, 0, 3.3, right? Now let's assume in our data, maybe data gotten from anywhere given to us, we want to count how many times do we have 3.3 appearing in that data. So, for example, now that TSU alumni example that I gave, they can ask, okay, how many TSU alumni, right? Actually, at the time they collect that data, actually their age is 60. At the time because so maybe they are getting the information when TSU is 60 years old. I'm just giving that an example. So how many of them were actually born in the year TSU was created? So that means if TSU is 60, then you have to look for how many of those people are age 60 as at the time they got that information. They collected that data. So like I said, you can't be counting how many of them are 60 years old from a list of maybe over 100,000 alumni. It's not possible. But with Python, you can create code like this and to tell you these are the number of people that have their age equals to 60. So that is what you are doing. So for instance, in this case now, how many of these people, how many value in this list has 3.3? And to do that, we define so we call that occurrence, can't underscore occurrence. That's what the name we give to it. In brackets, my list, right? So my list is the data that we've collected that has the information. Now, to do that, we need to create what is called a counter. That counter will be the one that will help us to count. So the count here is 0. That's the beginning. Now, for element in my list, for every element in my list, my list is the one that has this one, that has the age of every TSU alumni, right? Or the value here. So for every element, so what that for every element means is Python is going to start looking at the age of everybody one by one, one by one, one by one. So for every element in my list, so the first age on that in your data, Python will look at it. So if that age is equal to 3.3, right? Python will count it. So the first one is 3.3. I count it. So now, don't forget our count is 0. So it now be count plus 1. So for instance, let's look at this. When this is the list, the data we are looking for, right? Now, when the count is the first thing is going to do for element in this, we are looking for. So if the element is equal to 3.3, that's the first one is 3.3. So count is going to be 0 plus 1 because you have seen 1, right? If you go to the next one, is this 3.3? No, our count is still 1. The next one, still 4, is not 3.3. This is 2.1. This is 1.2. At this point, this condition is met. 3.3. So if element is 3.3, that at this point is 3.3, count will now update 1. Our count is now be 1 plus 1 now, making 2. So count is no longer 1, count is now 2. Go again. Is this condition met? No. This condition met? Yes. So how many times that this condition is being met? So what will be added to count in this condition? So when you run this, that's 3. So 1, 2, 3. Do we get that now? So that is the way Python works. It will take it so when used for item, element, or whatever one you want to call it, in that data, that means you are telling Python to start taking it one by one, by one, by one, by one. So when you have that list of TSU alumni, Python will start taking them, though it's a very fast process as far as Python is concerned, compared to when you are looking at it one by one. It will take it one by one and it will tell you how many of those people has their age equals to 60. So let's run an example here. Let's run an example here. Let's use what we have here already. So let's so define, let's say TSU underscore alumni underscore age. For instance, I'm just giving that in brackets age, right? And don't forget, I used to tell you when you have this function, def for I, Y, S, if you always put a colon. And when you press enter, it will automatically assign an index. Now, so let our count equals to 0, right? Now, so for item, okay, yeah, for item in age that we are supplying in age, right? If item equals to 60, right? So the count. So what this is saying is Python is going to look at this age, right? Age that is being supplied to us. So let me call it age data. Let me call it age data, right? Let me call it age data being supplied to us from TSU alumni, right? So what that is saying is Python. So we are this age data. This data will be supplied by whoever that is giving you the data, right? Now we said count is equals to 0 because we have not started counting. So let our counting that we've done equals to 0. Now, so for every item in age, right? If that item equals to 60, so we want to count, our purpose there is to count how many TSU alumni is age 60 at the year 2023, for instance. So for item that is equals to, anytime there is the item, the age there is equals to 60, let that be a count, right? So once that is achieved, right? Let's now update our count. So count should now be equal to count plus 1. Now our count is 0 because we've not started counting. The moment there is one item, one item equals to 60, let count update itself to say 0 plus 1, 1, because we have seen an item that is equal to 60. When we also find another item, it will also come back again to this place and see if this condition is met. It will also add that count again to the already existing count. Are you getting it? So you can now say return or return or print return count. So this is what will give us how many times. Now this is what is going to give us how many times age of TSU alumni in our script is up to 60. So let's now go and supply the information now. So let's see the age data that is sent to us, right? The age data sent to us, age data sent to us from TSU, whoever that is collecting that information for TSU. Let's see if the age data is from, let's say, 20, 60, 70, 60, 80, 90, 60, 50, 67, 61, 60, 89, 100, and 60, right? That is the data given to us by TSU, right? So now we have to go and put that data into TSU Because don't forget, you already defined TSU alumni. TSU underscore TSU underscore alumni age, right? In bracket, the data given to us now, age data. That's age data, right? So let's calculate count. So what is how many times do we have 60 in this thing? How many times? Python says 5 times. Can we count this please now? 1, 2, 3, 4, 5. Can you see how easy it is for us to know how many alumni as their age equals to 60? The same way, if you have 1 million data, that is how fast Python is going to give you that information. But if the information, if you don't know this code, you will have to start taking their name one by one and start counting manually. Do we get the point now? So that is it. So any question before we call it a day for today? You know, because of explanation, we couldn't finish this aspect. So that is where we are going to start next week. Because it's good to lay this foundation. And like I used to say, you have to practice. I'm telling you. Go and ask people that are working on Python. Ask them before you become a guru or an expert in Python. Did you just take it at your own will, or you have constant practice? I can tell you, they will tell you they practice a lot. So please go. It's a matter of you thinking and imagine everything that you have learned. I'm telling you, that is it. And constant practice. I admit it is not that easy, but with constant practice, they say practice makes perfection. That is it. And that is how it works. So any question from anyone before we call it a day and we meet next week? Do we have any question, please? So we are going to meet next week, right? The same time. Next week, we're going to meet next week, same time. So I'm going to send you the assignment, the exercise, right?